Hello and welcome to SudoKanard. We're here to solve this Battenburg Little Killer Sudoku by Siniša Hrga from Croatia. It was the highest pointer puzzle in the latest WPF Sudoku Grand Prix, and I was very well prepared for this type of puzzle, and yet I gave up pretty early because I missed one easy deduction, which is a pity because this puzzle, in spite of the high 87 points, is quite approachable. So the special rules with Little Killer, well, this is the sum of this digit, this is the sum of those two digits, and so on. And this symbol, the Battenburg pattern, means that on one of the diagonals you have two even digits, and on the other you have two odd digits, and all symbols are given, which means that if you don't have such a symbol, then you don't have such a parity pattern in the four corresponding cells. So let's start with coloring. So I will use orange for odd and green for even. And you can see that this is a 3, this is a 9, this is a 4, this is a 5. So we have already such coloring. And the place where you can start coloring the cells is just here in this column, because we already have 3 odd digits, and we know that here we have one even and one odd. The same happens here. So we have allocated all odd digits in the column, because there are 5 odd digits in total, so those are 2 even digits. And that is a beginning. Now those digits have opposite parity, but I can't put them this way, or there would be a symbol here, the Battenburg pattern, so those digits are in this order, and with all the clues we can color all those cells. Here there is no pattern, so this is odd, and here we can just extend the coloring. Here 17 is an odd sum, those are even digits, so this has to be odd. And we can color all those cells. Here we don't have the pattern, so this has to be odd. Here we don't have the pattern, so this has to be odd. And then this 13. That's an odd sum. Those digits have an odd sum, so this is even. And this has to be odd. And actually, I could have found that by just considering how many even digits I had in those columns. Now, this row already has 3 even digits, and we need another even digit here. And we have exactly 4 even digits on the row, so the other digits here are odd, and now this Battenburg pattern can be completed. Here no Battenburg pattern, so this is odd. Here no Battenburg, so this is odd. This row still needs another even digit. 14 is even, so the sum of those 3 digits must be even, so this is odd. And I could have found the parity of this cell with this 42 as well. This 14 now, we have 3 odd digits, that's an odd total with an even digit that's odd, so this must be odd to have an even sum. Now where do we look? This row already has 4 even digits. And well, this 24 could have told us as much. This region already has 4 even digits, so those are odd. Here we need another odd digit. If I try to put it here, then this has to be even, and I create a Battenburg pattern. So this has to be even. That's 4 even digits here, so this must be odd. We need 2 more even digits in this area, and actually we need 4 even digits on this row. This column needs a 4th even digit, which is here, so this is odd. And now we need this column needs a fifth odd digit, and this row needs a fourth even digit. Now this column needs a fourth even digit. It will be here, so this is odd. This row needs another even digit, 15, so this must be odd. And this column still needs one even digit. 16, we have an odd sum, so this has to be odd. There's no Battenburg symbol here, so this is odd, odd, even, even. And the last digit here is odd. So this is done for the coloring. Now let's move on to Sudoku. So this is a 3, this is a 9, this is a 4, this is a 5. Now, where do we look? So those digits here and there must be 5 and 7. But 7 wouldn't work here with the sum of 7, so this is a 5 with a 2, and that's a 7. Now, what about this 15? Well, there are quite a lot of options. Here in this column, those are 6 and 8, but there's an 8 here. So this is 6, this is 8. This row needs a 2 and a 6, but there's a 2 here. So this is 6, this is 2. Those are 4 and 8. But then let's look at this 17. So this plus that is 13, is 11, sorry. 8 would come with a 3, 4 would come with a 7. Those must be 6 and 8, but there's an 8 here. Those must be 2 and 6. And here, 24, that's 15 already, so this plus that must be 9. 5 is not available, so that's not 4. This is 1, and this now will be 3 or 7. Now this 17 puts a 7 here, and that's a 3. Here this is from 1, 3, and 5. 8 here tells us that this plus that is 8. This 5 says this is not 5, so this is not 3. This is 3 or 7. This 6 is not here, so this is 6. In this column, that's a 4, that's a 2. This is 4 and 8. Let's focus on even digits. In this column, that's 2 or 6. With 4 and 8, those are 2 and 6, but there's a 6 here. And this is now 4. 4, I said. At the bottom, I still need 6 and 8 here. So those here are 2 and 4. 2 and 4 here, so those are 6 and 8. But with those digits, the answer can be found. 8 is not here, so it's here with a 4. This is 2 and 6, but we have a 2 there. That's a 4, that's a 2, that's a 4. 8, 6, 4, and 8. So all odd digits haven't been placed. Now this column needs a 1 and a 5, but there's a 1 here. Here we need a 3 and 5. Here we need 7 and 9, but this 13 clue needs a 7 here and a 9 there. Those here are 1 and 7. Those here are 1, 3, and 5, but this is not 5 because of this. Where do we look? This 24 is fulfilled. This 15 here needs a 9 there. So those are from 1, 3, and 7. So this is 3 or 7. 1, 3, or 7. This 14 now is interesting because this plus that is 10. So the only option is to have a 3 here, a 7 there. So that's a 7, that's a 1. That's not a 1 anymore. This row needs 1, 3, and 7, but there's a 7 here. Oh, here I need a 1 and a 9, and that's a 1. So 9 goes here, that's the 1. 9 does not go here, so 9 is here. And this is 3 or 5. This 24 must be done now. Yes, it is. Here I need 5, 7, and 9, but that's not a 9. So the 9 is here. Perhaps there's something to be done with that, but first, this is from 1, 3, and 5. No, 5 is here, sorry. So this is from 1 and 3, and this is from 1, 3, and 7. This 14 is actually interesting. Here I need a 3 and a 5. So that's 8 already. The remaining 2 digits must sum to 6, so they must be 3s. And that's a 5. This 3 puts a 5 here, so up there I get the 1, the 3, the 7, the 5, the 3. That's a 5. That's also a 5. Up there, that's a 3, that's a 5. That's a 1. So a lot is happening. This is 7 or 9. Here I need 7 and 9. So this now can only be a 3. That's a 1, and that's a 7 or 9. So we are left with some seemingly deadly pattern, but this here will be disambiguated by the 28. We already have 11, 15, 16, 21. So this has to be a 7. So those are 7s. And those here are 9s. So really, this puzzle wasn't that difficult. I just missed something easy, which was just what happened in the last column for the first step. The rest was really not that hard. So the 87 points were certainly deserved because the solve needed time. You needed time to do the coloring in the first step and then placing the digits. Even if placing the digits really was not difficult. There was no advanced logic in it. It was just long. So thanks for watching this video and see you soon on SudoKanard.